Good morning, physical science students. I just realized that it still said day one up here. We are actually looking at day two for acid bases and solutions. Day two, acid bases and solutions, we're looking specifically at elements D and E. We are talking about acids and bases. So we're going to discuss their properties, a little bit about pH, and a little bit about neutralization reactions. So let's define what an acid is. So by definition, an acid is a substance that contains at least one hydrogen atom that can be removed when the acid is dissolved in water. So an acid is something that produces hydrogen ions in solution. For example, HCl, hydrochloric acid, when we put it in water, H2O, that hydrogen ion separates and forms what is called hydronium, that H3O, plus, and leaves the chlorine ion all out in the cold. Acids are also sometimes referred to as a proton donor because a hydrogen ion has lost its electron, doesn't typically have any neutrons, therefore that's all that's left is the proton. A proton is also a hydrogen ion. Oh, I happen to pick the exact same example as what's in the slide. But hydrochloric acid, hydrobromic, I don't have my periodic table handy, sulfuric acid, all of those have hydrogen ions that they release when you put them in water. Now, a base is a substance that forms hydroxide ions. It has OHs that it gives up. So, for example, bad misreadings, calcium hydroxide. Calcium hydroxide, when we dissolve it in water, that calcium is going to, I don't know why I keep drawing a G, but whatever. That calcium is going to separate into its ion, and the OHs, that hydroxide, are going to form their ions. Now, bases can also be classified or are also considered substances that can accept protons. So they can accept an H plus. Sorry, I was trying to think of an example off the top of my head. Oh, there we go. Ammonium. So ammonia, cleaning chemical NH3. Ammonia can steal a hydrogen from water and form ammonium, AMMONIUM. And it produces, again, that OH in the solution. It produces that hydroxide. So that is a non, hydroxide compound that actually is considered a base. Now, indicators are substances that we use to determine or to detect a pH change or a specific pH. There are several different indicators depending on the order that we do this lesson. You may have actually seen a lab where you dipped strips of paper into the liquids and the papers changed colors. That is one type of indicator, litmus paper. We have red and blue litmus paper. With your litmus paper, if they are both red, it is considered an acid. If they are both blue, it is a base. So acids are red, bases are blue. I love chemistry. You should too. Now, besides litmus papers, we have phenolphthalein. Phenolphthalein turns between clear and pink. Goldenrod turns between yellow and red. There's also a universal indicator that has like 6 different colors. Cabbage juice, red cabbage juice, will go between pink and green. So all of these are things that will change their color depending on the pH of the solution. Now we're talking about our properties of our acids. Acids and bases tend to have opposite properties, which kind of makes it a little bit easier to remember. So your acids tend to stay sour. If you've ever had a lemon or a sour head candy, you've consumed an acid. Acids have a pH of less than 7. On our pH scale, pH goes from 0 to 14. And that looks like an H. 0 to 14. So acids have their pH that is less than 7. Acids are going to be corrosive. All that means is it's going to break down other substances. If you put certain acids on certain metals, you're going to get gases that are going to be produced. If you put acids on like some clothing or other substance, even skin, depending on the acid, it will eat through the substance. Let's try light blue. So my pH scale goes from 0 to 14, and acids are less than 7. So acids also tend to be electrolytes. All an electrolyte is a substance that can conduct electricity when either in its liquid form or when dissolved in water. So you'll notice that you've probably seen or read the term electrolyte before. Electrolytes tend to be very common in sports drinks, and that's because the electrolytes are needed for your brain and your body and your muscles to conduct electricity. And like I said earlier, acids are going to turn your litmus paper red. Bases tend to be bitter. One last thing, acids will react with metals to produce a gas. Most acids will react with metals to make a gas. I don't know why it's not on the screen, but that's okay. So like I said, acids tend to have a bitter taste. Dark chocolate or soap might be something that you've encountered, that you've gotten in your mouth or eaten on purpose, that have bitter taste. They both contain a large quantity of bases. Bases also tend to have a pH above 7. Bases are also corrosive. So notice that's a property that they have in common. They are both corrosive. Additionally, they are both electrolytes. They both can conduct electricity when melted or when dissolved in water. Now, bases will turn our litmus paper blue. Acids are red. Bases are blue. I love chemistry. You should too. But bases tend to feel slippery when wet. Acids just feel like water if you have just the pure sample of the acid. But bases always feel slippery. So think about soap and shampoo or bleach. Things that you've gotten potentially on your hands that feel slippery probably have some base in it. So what are some of our uses for acids and bases? Well, we encounter it a lot in our food. But some things that might have acids in it that you don't realize. So phosphoric acid, H3PO4. Phosphoric acid is found in cleaning detergents, it's found in fertilizer, but it's also in some sodas. Sulfuric acid, H2SO4, it is in car batteries. Very concentrated in car batteries, very dangerous to mess with. But in lower concentrations, sulfuric acid is actually a fertilizer. That SO4 is what some plants need in order to grow quite well. Hydrochloric acid, HCl, that is actually in your stomach. It is your stomach juices, your gastric juices that help dissolve your food. And acetic acid, C2H3O2, is what is in vinegar. So if you've ever had pickles, you've seen the byproduct of acetic acid being mixed with cucumbers. What are some of our uses for our bases? Bases don't tend to find in food as often. The dark chocolate is kind of an anomaly. But other bases, sodium hydroxide, for example, is used as a drain cleaner or an oven cleaner. It's also used as lye. I can't remember what lye is used in. Magnesium hydroxide, MgOH, that is a laxative. It's also found frequently in your antacids. So if you've ever had Tums or I can't think of what the other brand is called beside Tums, but it's probably got magnesium hydroxide in it. Ammonia, as I mentioned earlier, NH3 is found in cleaning chemicals. It's also a common ingredient in your fertilizer. So acids and bases, let's look at their concentration and what is pH. So a strong and a weak acid or base. It just gives you an idea of how much the acid or the base disassociates. Strong acids or strong bases ionize 100%. That means when I put it into the water, it's going to form 100% of the possible ions. Weak acids or weak bases ionize considerably less than 100%. Typically, they're even less than like 10%. Even some of them are only form like 0.1% of the ions. Now, a concentrated solution is a solution that has a lot of acid or base. It is possible to have a weak acid that is very concentrated. It just means you've got the most possible ions in that present. It's also possible to have a strong acid that is diluted. You only have few particles of that acid in the solution versus a lot of water molecules. So strong just tells you how many ions you make. It doesn't give you an idea of the concentration. Weak, again, gives you the idea of the ions, not the concentration. Now, the strength of an acid or a base depends how completely it separates into the ions. Ions are the things that carry those electric charges. So your strong acids are going to tend to have be strong electrolytes. Your strong bases are going to be strong electrolytes because they can carry a lot of electricity because they have a lot of ions. Your weak bases and weak acids tend to be weak electrolytes because they have very few ions within which to carry the electricity. So what are some strong acids or strong bases? Our strong acids, some of the ones that I mentioned earlier, that HCl is a strong acid, H2SO4 is a strong acid. They form 100% of their ions. Our strong bases, bad Miss Rains. Most of your group 1 metals form strong bases, lithium hydroxide, potassium hydroxide, as well as many of your group 2 elements. So calcium hydroxide and strontium hydroxide, for example, are some strong acids, strong bases. Oh, there they are. See, I knew they were in there somewhere. So your weak acids, weak bases do not ionize 100%. They have less than 100% ionization, and I'm telling you honestly, guys, gals, they're nowhere near 100. They're like 1%, 0.1%. They have very, very few ions. When you have a strong electrolyte or a strong acid and a strong base, and you run electricity through it, you get a bright light. So that's one interesting thing to note. Your weaks are going to be opposite. So less than 100%, very, very few ions. They are going to have a very dim light when you're running electricity through it because of the few ions. Some examples include ammonia, that NH3, as well as acetic acid. So that acid that was found in vinegar. They're both weak substances. So acetic acid being the weak acid, ammonia being a weak base. And I think, in my opinion, they got the pictures flipped, but a strong is going to have a bright light and a weak is going to have a dim light. So some acids that ionize almost completely in a solution are your strong acids: hydrochloric, nitric acid, HNO3, sulfuric acid, H2SO4. Their pHs tend to be less than 2, so they're at the very end of the pH scale. Anything that is not a strong acid, their pH tends to be above 2 but below 7, so between 2 and 7. Your bases that are strong bases, they tend to have extremely high pHs. They're at the upper end of the pH scale, that 13, 14. They're above 12. Your weak bases tend to be between 7 and 12. We'll write it again in a little bit. So pH scale is just a measurement of the hydrogen ion potential. It tells you the concentration of the H plus ions in solution, and it also gives you an idea of the concentration of hydroxide ions in solution, your OH meters. your OH ions. We measure it with an indicator or with a pH meter, but when we're looking at our pH scale, this 7 is neutral. 7, you have to be exactly 7 to be neutral. And as I said earlier, your weak acids tend to be between 2 and 7. Your weak bases be closer to that 7, so between that and like 12. And your strongs are at the end. That was not the button I wanted to hit. Things that have a lot of ions are going to have the very highest or the very lowest pH. STRO in strong acid and strong base. So we, of course, will do our lab where we're going to determine household substances, what their pH is, if they're an acid or if they're a base. But here are some common things and their relative pH. It is important to note that pure water at 25 degrees Celsius, which is basically room temperature, has a pH of 7. It is one of the substances that is typically neutral. A lot of your foods tend to be acidic, so we've got coffee, tomatoes, wine, vinegar, lemon juice. Those are all foods. They all are weak acids. A couple of your strong acids that you might encounter, your gastric juices, your stomach acids, as well as battery acid. Those are 2 strong acids. For our bases, you've got blood, seawater, sodium bicarbonate. That is baking soda solution. Borax, that's a cleaning salt. Milk of magnesia, that's the other name. That's something that you eat when you've got, or consume when you've got acid reflux or an upset stomach. Detergents, ammonia, those are all your weak examples of weak bases. Some strong bases, bleach and sodium hydroxide, NaOH. Those are both strong bases. So, neutralization reactions. With a neutralization reaction, you have an acid and a base that reacts with each other to produce water and a salt. An acid will always react with a base to produce water and a salt. Now, it may not be table salt. A salt, remember, is just another name for an ionic compound. My M did not look like an M, but whatever. So let's say I had sulfuric acid, H2SO4, reacting with, lithium hydroxide. My water, it's water, H2O, but my salt is going to be lithium sulfate. So in this particular situation, that is my salt. It is an ionic compound, and then we've got our water. So when you've got your unmixed reagents, when you've got the acid and you've got the base, especially if they're strong acids, strong bases, they're going to be completely ionized. When you mix them together, the water that they're mixed in still hangs out there, but you also produce additional water. And depending on the salt produced, you're going to have either your salt ions floating around, or quite possibly you might actually make a precipitate. So you might have a solid that falls out of the solution. Most of the ones that we play with in a laboratory setting for chemistry, they tend to stay ionized. They tend to stay as ions in their solution. So this is kind of showing what portions of the ions are coming together to make what products. So my H and my OH come together to make the water, and the other 2 things come together to make the salt. And I don't know why it's brownish. I guess it's that indicator. So whatever the indicator is that they used that made the acid red, because hydrochloric acid is not naturally red, it is naturally clear. Its indicator turns it to that ugly brownish color. Now, neutralization reactions will not always result in a pH of 7. You will only get a pH of 7 if you have equal concentrations of acid and bases, not something that we are going to play with in physical science. But just because I mix an acid and a base does not mean I'm going to have a pH of 7. If I have more acid, my pH is going to be lower than 7. If I've got more base, my pH is going to be above 7. So take a moment and see if you can identify the acid, the base, and the salt in this neutralization reaction. So acids are always substances that have hydrogen ions. So my hydrogen ion is going to be HNO3, that's nitric acid, not that you need to know the name. My bases tend to end in OHs when we're talking about a neutralization reaction. They tend to end in OHs, therefore that's going to be my base. My potassium hydroxide. The salt is the product, it's not the water. So my potassium nitrate, KNO3, is going to be my salt. I don't know why I have to hit it twice. So that is it for today. As always, make certain you upload your notes to Google Classroom and complete the corresponding practice assignment that is posted with today's assignment. If you've got any questions, feel free to either hop in my open office hours or send me the question through the comments in Google Classroom. That's all, and I'll see you next time.